Hello, everybody. Welcome back. Today, we're going to be talking about measures of central tendency. So, what do I mean by central tendency? So, that's a value that is supposed to describe the center or middle of the data set. So, this is the point of central tendency, is to figure out where the middle is. Okay, so let's talk about the central tendency methods. But before we do that, I want to quickly go over one other definition that's important, which is outlier, which is the value that is much larger or much smaller than the others. So let's say, for example, that the data set shows the marks that people are receiving in grade 12 data management. And let's say most people are receiving 70s, 80s, there's a few in the 90s, maybe there's a few in the 60s, but most people 70s and 80s for the most part, unless it's, a special class or something like that. It's probably going to be that. I know in some special classes, maybe most people are in the 90s and the outliers are people who are only getting 70 or something, but in general, in most classes, probably 70s and 80s are the most common marks, followed by 90s and 60s, and then followed by everyone else. So outliers in that case might be the one student who didn't show up for any of the tests or exams and has a 0 in the course, or the student who is really, really struggling with the course and is only getting 20%, right? Those would be the outliers because those values are much smaller. Those marks are a lot lower than most of the other students' marks are. Let's say, for example, our data is measuring how long it takes for the school bus to get to school each day. And one day the school bus gets a flat tire, and so they have to call in, roadside assistance because for some reason the bus driver didn't think that it was important to have a spare tire. So it took an extra 2 hours, and so it took way, way longer for the students to get to school that day. They were all late thanks to this lack of preparation, this lack of planning on the school's part. That would be an outlier day because maybe most days it only takes 30 minutes to get to school for these students. But on this day, it took about 2 hours and 30 minutes to get to school by the time they actually got there. It might have been faster to just, send the students in cabs or something. But anyway, or get another school bus, but they didn't do that, unfortunately. So those would be some examples where we have an outlier, or we have one, piece of data or two pieces of data, or three, or any number of outliers, but usually outliers are not that many, right? Hence they're outliers, right? That are far from the rest of the data. So that's an important term to know what that means, and I wanted to go over that before we move on. Okay. So for this one here, this first type of measure of central tendency is called the mean, also known as the average. So here it says the formula for finding the mean is to take all the values, add all the values up, and then divide by n, which is the number of values. So to find the mean here, I would have to add all these numbers up: 89 plus 90 plus 88 plus 91 plus 82 plus 90 plus 88 plus 88 again plus 86 plus 90 plus 92 plus 87 plus 89 plus 86. And this is 14 values because this is the mean temperature of, the daily highs in Ontario. I'm guessing this is in Fahrenheit because otherwise it would be burning up. In the last 14 days, right? And so we would divide this by the number of terms there are, which is 14, and then we'd get the answer. Unfortunately, the mean is kind of tedious to calculate, unfortunately, but that's how we would calculate the mean, is just by adding up everything and then dividing by the number of data points that we have. Okay, so in this case, we're going to end up with, let's see here, we're going to end up with 1,236 over 14, which is 88.3. So our mean in this case is 88.3 degrees Fahrenheit. Good. All right, so the next one is the weighted mean. So the weighted mean is used to calculate the mean when we have multiple values or different weightings for each value. So for example, a golfer during the week shot 73 times, 73 three times, 74 twice, and 76 twice. What is the golfer's mean score? Well, in this case, we can't just take the average of these three values, 73, 74, and 76. We have to account for the fact that the 73 occurred three times, right? So if we were to write out the data set, we'd get 73, 73, 73, and then two 74s, so 74, 74, and two 76s, right? So this is what the data set would look like if we were to write it out, right? So in this case, I'm going to add up 73 three times, which is the same as 73 times 3, plus 74 times 2, plus 76 times 2, right? Because we have to account for the fact that not all the numbers are just occurring once, they're occurring different numbers of times. And so the mean is going to be slightly more catered towards 73 because it occurred more times. And this is going to be over 7 because that's the total number of times in all that the golfer went, right? There was 3 times for 73 plus the 2 plus another 2 gives us a 7. So this will end up being, let's see, 219 plus 148 plus 152 divided by 7, which is equal to 74.14. So there we have it. All right, the next one has to do with mean of the group data. And by the way, these are all just variations of the mean or the average, but they are technically the same method of central tendency. So the mean of the grouped data. So in this case, what we need to do is when we are only given a few, a frequency table with ranges of data, we must use the midpoint of each interval to find our weighted mean, right? So in this case here we have age 16 to 18, we have 10 people in that category. Then we have from the 21 to 25 category, 18 people. Then 26 to 30, we have 12 people. And then 31 to 35, we have 8 people. And then 2 people from 36 to 40. So what we need to do is we need to find the midpoint in order to find the mean based on what we know. So in this example, car owners were asked how old they were when they got their first car. So let's see. So in this case, the middle age from 16 to 20 would be 18, right? The middle of 21 to 25 would be 23. The middle of 26 to 30 is 28. The middle of 31 to 35 is 33. And then the middle from 36 to 40 is 38. And this is likely to get us, on average, the most accurate estimate that we can of the average age, even though technically, we don't know the exact age, right? Maybe all of the, people in the 16 to 20 category were more like 19 or 20. However, from this data set, we can't actually know that, right? We can't actually know, even though I do think from a financial standpoint, that's a bit more likely. But anyway, that's we're going to do it this way, where we just consider the middle of each, of each age group. Okay, so to do that, we're going to do 10 times 18 plus 18 times 23 plus 12 times 28 plus 8 times 33 plus 2 times 38. And then we're going to divide that by the total number, which is 50, right? If we add up all these numbers, 10 plus 18 plus 12 plus 8 plus 2, that is going to be 50. Okay, so we're going to end up with 1,270 divided by 50, which is going to be 25.4. So therefore, the approximate mean is going to be 25.4. And you know what? That sounds about right. That sounds about right to me. Good. All right, so those are some variations of the mean. Later, we'll talk about, what are the positives about the mean? In what ways is the mean a good form of central tendency that accurately tells us where the middle of that data is, and also limitations of the mean. So, what does the mean not account for as much, for example? So we'll talk about that. The next one is the median. So the median is when we arrange the data from smallest to largest. The median value is the value in the middle. So if there's an odd number of data, it's just the value in the middle. If we have an even number of data points, that means there's actually going to be two middle values, and we just take the average or the mean of those two middle values, and that's our median in that case. So one big thing that's really important is to make sure that the data is either arranged from smallest to largest or largest to smallest, because if the data is just arranged in some random order and we try to find the median, then the median doesn't mean anything, right? We could just rearrange the data in any way we want and make the median anything we want, and that isn't going to make, any sort of sense. So it's important to make sure the data is arranged properly before we attempt to find the median. Otherwise, we're not going to get a very accurate form of central tendency. So this example says if the number of minutes that Arya spent exercising each day over the past week are 35, 38, 32, 40, 45, 42, and 36, find the median. So what we first must do before anything else is we must rearrange this from smallest to largest, or largest to smallest, whichever we prefer. They must be arranged sequentially. So I think the lowest one was 32. So there we go, 32. And then we have, looks like 35 is the next one, then 36, then 38, then 40, then 42, and then 45. Let me just check. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Awesome. Okay. So now what we're going to do is we're going to find the middle value. So I'm going to start at each end, and we're going to go one in here, one in here, one in here, one in here. One in here, one in here. And we landed on 38. So 38 is that middle value. Now, let's say that you do not want to do it by hand. Maybe you have 100 values and, going like this 100, 50 times isn't going to be accurate, right? It's not going to be good. Then in that case, what you'd like to do is, say, well, there's 7 values in this case, and it's the fourth value. So, right, so it's the number of terms, n plus 1 divided by 2, that's the term, right? So in this case, it would be 7 plus 1 divided by 2, which is 4. So that means term 4, which is, the fourth term, is going to be the correct one, right? So that's how we can know, well, which number, which term is it, right? It's the fourth one in this case. So there we go. Very good. So therefore, median would be 38. Here we have another example where there's an even number of data points here. So let's try this one as well. It says the number of wins by a basketball team over the past 8 seasons is 58, 45, 27, 48, 54, 52, 49, and 39. Find the median. So for this one, what I'm going to do is same thing as before. I'm going to list these in the correct order. So 39 is the smallest one, so I'll put that one first. Then what's next? There's some 40s. Looks like there's 45. Oh, I missed 27. Oops, I'm actually going to put 27 over here then because it is actually first. And then we have 39 and then 45. Anything else with 40? Yes, we have 48, 49. So I'll add those. Amazing. And then we have 52, 54, 58, 52, 54, 58. So I'll use the same method as before, and we're going to find the middle one. In this case, we actually got 2 middle ones, 48 and 49. So what I'll do then is I'm going to find the mean of those numbers, which is going to give us 48.5. And so that is our median. And it may seem strange that, wait, this median is not actually something that's even possible, right? It's not possible to get half a basketball point, but make no mistake, this is still the median. Okay, this is still the median, even though it's not actually even a point on this set, because it is halfway between those 2 middle points that we found. Okay. All right. So for this one, how will we figure out which ones to, which 2 points to take the middle of, right? Well, in this case, we have an even number. And so we're going to do n over 2 and n plus 2 over 2, right? In this case, it would have been 8 over 2, which is 4, right? And 5, or sorry, 10 over 2, which is 5. So the fourth and the fifth term are going to be the terms that we're going to choose to take the average of them and get the answer. Now, sometimes the middle two terms might be the same, in which case the average of two things that are the same is just that exact value. So that's also a possibility as well in certain situations. Very good. All right. Let's talk about the mode. So this is the data value or interval that appears most frequently. If none of the data is repeated, then there is no mode. If two or more data values occur an equal amount of times, there might be two or more data values that are the mode. So, for example, the number of wins by a hockey team over the past 10 seasons is 55, 45, 37, 58, 54, 52, 49, 55, 56, 55. Find the mode. Well, I think I said 55 three times, and I don't think there's any other number that I even repeated. So I'm going to say 55 is the mode because it occurred the most number of times. Now, I will say the mode is not a very good form of central tendency whatsoever. There's a lot of limitations to the mode. I mean, there's limitations to all of these methods, but especially to the mode, because it's possible that, if there's a large group in one place, that, there's also other parts of data that we're completely missing in that are not really much included. Not to mention the fact that there are some data sets that have no mode, or some data sets where it might be debatable, what is the best mode, or that sort of thing. So mode has, I feel, a lot of limitations to it, and kind of a lot of guesswork. It really only tells us, there's that most of the data points are here. Well, what about things that are happening, around that point? Are there other factors that we got to consider other than just this exact point, occurs the most kind of thing, right? How many points are around that data point, or are there, other data points that are just, randomly all over the place, or do they all really center in on this mode? Well, who knows? Who really knows, right? Good. All right. So let's talk about which one of these is the best and why. Okay. Which one of these is the best and why? So, because all of these have, their strong points, and all of these have their limitations. So the first one is the mean. It says when the data is roughly symmetric, mound, or uniform, then mean is the best way to do it. Now, why is that? Well, because the mean accounts for every single data point there is, and takes it and finds that middle. So the mean is going to be the best for the data being roughly symmetrical. It's going to find a good, accurate, it's going to be most accurate. However, the median is better when the data contains outliers or is skewed somewhat, right? So let's say, for example, the data is not very uniform, that there's a case where it's skewed to one side or the other. So, for example, let's say I'm asking people what their income is. Well, the thing is, most people's income, I think the average household income is around $80,000 a year in Canada. I think so, or around that point. So probably most people's household incomes are anywhere from, let's say, $40,000 at the low end to $200,000. I think that's a pretty good range where most people lie in. However, there are some outliers, right? There are going to be some people, if you ask a kid that question, they might just tell you that they make $10 a week for allowance, which is very little money in comparison to what the average Canadian worker makes, right? So, yeah, or it's also possible a kid wouldn't be part of the population as well, depending on, who the population is exactly. Right? So they would be an outlier. Or another example would be someone who makes a ton, tons of money, right? How about somebody who's, a business owner who's making, $1 million every single month from their business, right? Well, $1 million a month, that's 12 million a year. That is a lot of money. That person's making more money in a month than most people even have as their net worth, right? Especially younger folks. So that person is most certainly an outlier as well. They're making far more than most other people are making. And so they're going to really skew up the mean and make it seem like people are better off, than they actually are, right? Because it's true that a few people are really, really, really well off. And so they're going to make the average household income kind of go up, right? Whereas they will not affect the median household income whatsoever, right? Or let's say we're looking at what grades, how well did students do on their last test? Well, maybe two students decided they didn't want to write the test, or they slept in, and so they received a mark of 0. But most of the students did really well on the test. The test was pretty high scoring. People were getting around 90%, or maybe a bit above 90% was the median. Well, in that case, the mean would be a bit below the median, because the two students who didn't show up at all and received 0 would be skewing would be skewing it down to make it look as though the test didn't go as well as it actually did for most people, right? So whenever the data is skewed or has outliers, the median is a better representation of the middle, because the outliers are very far from the other data points and they're not something very common. Now, how about mode? It says when the data frequency is more important, or the data looks as though it has two means, right? So in this case, there's a couple different places where the data kind of peaks. And so looking at the modes is going to be the best representation here, because if we just found the mean or the median, which is only one number, well, we're going to get something probably in here if we look for mean or median. But that doesn't tell us that actually there's pretty high peaks over here and over here, right? It doesn't tell us that, whereas the mode does tell us that, right? So that's why that's important. Now, most data doesn't look like this one. Most data will talk about like normal distributions and roughly normal distributions, things like that. But if you do happen to have a data set that does look like this for whatever reason, then the mode can be a useful thing in that situation. Absolutely. But yeah, that is it for methods of central tendency. Next time, we're going to talk about measures of spread, so quartiles and percentages, because today we really just talked about how can we find the middle of the data set. I want to also talk about how can we figure out other parts of the data set, because it's not really just the middle of a data set that we're typically interested in. We're typically interested in the entire thing. And so we'll talk about different methods for figuring out that moving forward. But yeah, that is it for today. I will see everybody for the next class. Bye, everyone.